Hello, on this video I'm going to talk about C++ if and else statement. Before I talk about the if else, let's talk about the relational operators. So the relational operators are these ones right here, and they are the greater than, less than, greater or equal, less or equal, equal, and not equal. So let's go over those really quick. So if I want to declare a variable, so let's say boolean b equals, and then here comes the expression that is going to be evaluated to true or false. All I'm interested now is some kind of expression that we will end up with true or false. So let's say I'm going to evaluate 2 is bigger than 3. So is 2 bigger than 3? The answer here is false. So if I display the b, okay, I am missing the namespace standard. Using namespace standard. All right, now I'm good to go. So if I display the b now, it's going to display false, which is 0. And here is 0, which is false. So that means 2 bigger than 3 evaluates to false. Okay, so what if I have 2 is less than 3? Now, is 2 less than 3? So this evaluates to true. Therefore, true gets assigned to b, and then when I display b, it should display 1 because 1 is true. So everything is good here. So something similar happens to the bigger than equal. So bigger than or equal. So is 2 bigger than or equals to 3? So the answer here is false because 2 is not bigger or equals to 3. All right, so how about 3? Is 3, and I'm going to remove the equals for now. So is 3 bigger than 3? It is not. So this evaluates to false. False is a 0. However, if I put an equal sign here, the question is a little bit different. The question now is 3 bigger than or equals to 3? The answer is yes. 3 is equals 3, so this thing evaluates to true. And true is 1, and we're good to go. All right, so the same thing happens with less than equal or the equal. So in this case here, is 3 equals to 3? And the answer is yes, 3 is equals to 3. So I got a 1 here if I run this program, and so on. Now, when it comes to equal, sometimes people make the mistake of putting 1 equals only. So this is wrong. The equal sign comes in 2. So it has to be equal, equal. This is the comparison operator, and this is the assignment operator. So if you remove 1 here, you're assigning. So this is wrong. This is a compiler error. So this is a comparison. Comparison versus assignment. So is 3 equals 3? The answer is yes. And then this will display 1. And the last one is not equal. So this is not equal. So is 3 not equals to 3? And this is false because 3 is equals to 3. So if I run this bad boy, I got 0, and 0 is false. So this expression evaluates to false. So the whole point here is that these relational operators will evaluate to true or false. And that's very important because it's going to be heavily used on the if-else statement. All right, so enough of relational operators for now. So let's move to the if-else. So let's do the if first. So the if statement has a foundational, and the foundation structure is if, then in parentheses, something that evaluates to a Boolean expression, followed by the body of your if. Okay, so let's take a look on the Boolean expression here. So the Boolean expression is something that evaluates to true or false. So here I'm going to put 2 less than 3. So if 2 is less than 3, then I'm going to print true. So this is a very simple if statement. And here I know that 2 is in fact less than 3. So this expression evaluates to true, and therefore the body gets executed. When it comes to the if statement, the body only gets executed if this expression evaluates to true. In other words, 2 is in fact less than 3. So if I run this program, it prints true. Now, this thing here, because it's hard-coded 2 and hard-coded 3, can be replaced by true. So if true, then prints the true. Now, if this thing here is false, then no matter what you do, this body never gets executed. So if I run this guy again, nothing gets displayed here because it's false. So no matter what you put in here, it must evaluate to true or false. Now, the second part here is the else, and the body of the else gets executed if and only if this part does not get executed. So if this is false, that means this will get executed. If this is true, then this will not get executed. So I'm going to put a message here. Say I'm the else. And because this is false, this gets executed. So let me run this. So I am the else gets displayed because this is false. If this is true, then this part does not get executed. So there it is, it prints the true. So the whole point here is the if-else statement. The if gets executed only if this expression evaluates to true, and the else gets executed only if this expression evaluates to false. Okay, so this is hard-coded. Let's go back to what it was before. So 2 less than 3. So this evaluates to false. Because this is false, this part of the code gets executed. So there it is, I got true. All right, but these are numbers, are hard-coded. I don't want a hard-coded number. I want to create variables here. So int x equals 2 and int y equals 3. And then now I can evaluate x and y. Now, as far as value is concerned, it did not change anything because it's 2, 2, and 3. But now I'm using variables. I'm comparing two variables. So I'm comparing variable x and y. So is x less than y? The answer here is true. Therefore, this gets executed and this does not. So no matter what you do, inside this parentheses, you must have a Boolean expression that evaluates to true or false. Now, you can make this expression as complex as you want. All right, so moving on, I'm going to now talk about the and also the or. So this is and this is or. So let's talk about and also or. So the AND allows you to evaluate two expressions into one. And the same thing with OR. It allows you to evaluate two expressions into one. So here we have one expression, but now I'm going to create more than one expression. So now I have two expressions. One expression here is x is less than y, and then I have a and x is bigger than 0. So in order for this entire expression to evaluate to true, this must be true and this must be true as well. So the AND says in order for this whole thing to be true, both sides must be true. So question now is x less than y? So x is 2, y is 3. So this evaluates to true. So this evaluates to true. And is x bigger than 0? X is true. X is actually in fact bigger than 0. So therefore this side of expression evaluates to true. This side also evaluates to true. And when you have the AND right here in the middle, this whole thing evaluates to true. So again, the AND, this AND evaluates everything to true only and only if both sides of the equation are true. So if I run this program, I get true because both sides are true. Now if one of the sides are not true, so this expression here evaluates to false, and therefore the AND will evaluate this true to false, because the AND, both sides must be true in order for this to be true. So if one side is false, the entire thing is false. And if I run this program, I get the else. So the whole point is the AND requires both sides of this expression to be true in order for the whole thing to be true. All right, let's take a look on the OR now. So the OR is on this symbol, these two vertical bars, and the OR says that if one side is true, the entire thing is true. So in this case here we have one side that's true, one side that's false. But the OR only requires one side to be true in order for this whole thing to be true. So if I run this, I'm going to get true because, well, one side is true. So how about if this side is true as well? If x is bigger than 0. So if one side is true, it evaluates to true. And if both sides is true, it evaluates to true again. So this is true. Now the last part is, what if this evaluates to false? So x is not bigger than y, so therefore this is false. And I want to put that x is less than 0, this is false. So if this is false and this is false, then the entire thing will be false because the OR requires at least one side to be true for the whole thing to be true. So because this is false, it evaluates to the else. All right, so you can make this as complex as you want. And true and or x less than 2 times y, or false, and whatnot. So you can make this expression as complex as you want, but if I were you, I would not make it that complex, because when something is too complex, then you should find a simpler solution for the problem. So this will work no matter what. However, don't do too complex. Every time you do something too complex, you may make a mistake, and I can guarantee that there's always a simpler solution. All right, so I'm gonna keep this very simple. And now let's talk about the if else, and then there's one more thing that I want to talk about, which is the else if. Here I have a if, else if, and else. So the if gets executed if this is true, and then the else if gets executed if this is true, and then finally the else gets executed only if this is false. But there's one thing here. If this is true, then this body will not get executed if this is true. So on a if else statement, only one item gets executed, and it's the first one that defines to be true. In this case here, I'm going to change to less than, and this here will evaluate to true. So because this evaluates to true, even if this is true, this will not get executed. On the if else statement, only the first body of code that has the Boolean expression evaluates to true will be executed. So I'm going to run this program. So it prints true here, and it did not print the second statement, even though this is true. So just keep in mind, only the first one that's true gets executed. And if I had another one right here, so now I'm causing this to be false, this should be true, and this should be true. So this is false, it won't get executed, but because this is true, it executes, and then once it finishes executing this body of code, it gets out of if else statement. So this thing here never gets executed. So keep in mind, only the first true statement gets executed. All the other statements does not get executed. So if I run this program, I get the second statement is true, but the third one, if the third one is true, it does not get executed. All right, so the last thing I want to talk about here is the nested loop statement. All right, so the last thing I want to talk about is the nested if else. That means inside a if else statement, I can create another if else here. So if x is bigger than 0, I can put something. So in other words, I have a if else statement inside a if else statement. So this is called a nested if else. So I'm gonna cause this to be true. So this is true now. So because this is true, it's gonna come here, execute this, which is true, display the true, and then it's gonna make this comparison if x is bigger than 0, which also turns out to be true, and therefore it will execute this line and not this line. So let me run this again. So it displays the true, and then display x is bigger than 0. Let me just put a end line here to be a little bit prettier. So it displays the true, and it displays x is bigger than 0. So the nested if else says you can have a if else inside the if else, but you must complete the entire thing. You cannot start here and end somewhere else here. So this if else must be completed, and the whole thing must be inside one body of code. And you can keep on going forever here. You can also have another if else statement here. So you can totally have this totally legal. That's a if inside a if inside a if. So you can make this as complex as you want. However, just like I mentioned before, If your solution for a problem is too complex, then I can guarantee there must be a simpler way to solve the problem and to create your algorithm. Alright, so that's all for this video. Thanks for watching.